let's review the answers you guys did on your activity. Okay? So, I've got 4 different graphs. Can you tell me what these graphs are called? Somebody besides those. You already went. Taylor, what did you say? What did you say? That one's called a histogram. I'm going to call it a bar graph, too. Does anybody know the difference between a bar graph and a histogram? Bar graph. Bar graph shows it individually. A histogram may touch. Does that make sense? Okay, what about that?
No, it's
Yes. That's like a stem-and-leaf spot. Is it a stem-and-leaf spot? Good. Alright, so this is the stem, like a branch. Like this is the branch that has a 1 in the 10th place. This is the branch that has a 2 in the 10th place. This is the branch that has a 3 in the 10th place. Just whatever it is, good way. And they still be. Okay. What else? What about this one? A box. It's called a box plot or a box. Oh no! It's called a dot plot. Okay, so can you guys see where all these relate? So I think we've all basically looked at the fact that they all start the same spot. This one starts at 12 and ends at 33. And this one starts at 12 and ends at 33. And this one starts at 12 and ends at 33. This one starts at 12 and ends at 37, but there's a reason for that. We're going to talk about it. Absolutely. You can have different pieces of data, right? And you can display it in different ways depending on how you want it to look. Correct? Yes. Yes. So, we're going to talk a little bit about that, but I'm glad that you said anything about shape. They all have the same shape, actually, as well. This one, that's not shape. This one has the same shape, it's just it's not, right? Yes. If I were to turn it, would it have the same kind of shape? Yes, ma'am. Doesn't this one? Oh, it's good. We're going to a little bit. Okay. And here? Pretty much the same shape? They're all the same shape. So deep. Now we can take a look at shape, right? Do they match? No. They do. This one only has one value and then a y and then a little bit more. What do you mean it's all the way up? Okay, hold on. The 18. But this is at 18. This is between 17 and 21. So here's all the values. Now that's a really good point. When you display data on different graphs, it's going to look different. Right? This one happens to show every single data set. You can see all of them. This one shows every single data set. You can see all of them. But this one, the histogram, lumps categories together. You can lump categories together however you want. We can say all the numbers between 17 and 30 and 30 and further out. And then we only have 2 bars. And that would be even less that we could infer, right? Yeah. There's 4 data sets in this. Between 29 and 33. Between 29 and 33. Between 29 and 33 would be right here. Aren't there 4 data sets there? Right. Okay, good point. Still a dot. Am I missing something? Oh, no. So, Philip wrote a good point. He says in wanting to go all the way to 37, but have to go to 37 because this is the same width, this is the same width, this is the same, they have to be the same width on Instagram. That's part of what Instagram looks like. Okay? I need you to move somewhere else. Yes. These are the actual depth values. So here, there's 2 26s here. Right? There's 3 28s. There's 1, 2, 3, 4 30s. You can see it in here. You can, it's between these values. So between 25 and 29, there's 5 values. Okay? Alright, let's use the other one. That's this one.
Yes.
All match? Yeah. Wait, match too, right? What's the hardest one to see? What's the hardest one to see because I haven't taught you this one yet, and it has to do not with value, but with percentages. Oh, okay, so we're going to learn this one out. But all of these other ones should be the same for you, but we don't normally look at them and compare them all at the same time. Okay, so we can all see that this one has a shape that starts here. Here. Okay. I should have one more. What do you think? What's different about this one? It looks like they're constant, right? But you couldn't say that these are all constantly 14 or all constantly like 17 or 20 or 24. Have a constant frequency. I like that. We're going to call this something special. All of them actually we're looking at, we're going to call them something special. Okay, so we have 4 different shapes of data distribution. We have, this one's called uniform. This one's called normal. We call it the normal bell curve. You've heard that before, it's a normal curve. Teachers all hope that your grades look somewhat like that. Actually, I wrote it and look like that. I wrote in my grades using the right. Unfortunately, mine, because it was bimodal. We're going to talk about that right now. And this one is to the left. Now, it looks like this one should be a right graph. Yes. Right? Yes. And that one should be a left graph. Yes. Somebody tell me what it looks like.
Oh, it goes like. I love marshmallows.
Yours is straight. Yours are also thin. Right? So if I'm going to talk about something being skewed, is this data over here skewed? No, it's big and fat and small. Big, right? Isn't it skewed over here, small and straight? Yeah. Little data? Yeah. So it's skewed to the left on this side. And skewed, my skewer would be on the right over here. Okay? The smaller, skewed They all look the same. You think about people that wear uniforms. They all the same, right? Normal curve. How does the normal curve look?
What?
Even on both sides. Even on both sides. It's very symmetrical on both sides. Okay, so let's go back to the data set. You do one? I heard it.
It's normal.
Uniform. The uniform. What about this one?
Right. To the right. To the right.
To the right. What about this one?
To the left.
To the left.
Normal. Normal.
Okay. So I couldn't have got that from you when you were first doing that. You go, well, look, your graph and my graph are right? But now you could, right? You could just look at those graphs. All right, let's keep going. All right, so your uniform and your normal curve are both symmetrical in your data set. All right, so statistics. Statistics is a lot like similar to a book, but with math. So some differences that we look at might be a spread of numbers. We look at how far away from normal it is. Right? That's how we look at a spread. The middle number, we look at the middle number. Sometimes. The average of numbers. Do you think about it being statistics? Basically the spread of numbers. Comes with pictures, right? Comes with percentages, but it's a description of numbers. You can also make your descriptors look the way that you want to. Correct? Like if you want to talk about salary with teachers, you want to say that one school makes more than another school does. Right.
The shade.
The shade. I'm just saying.
That's one shade.
One district makes more than another district does. Well,
The shade.
no, look at this. This is a perfect example because it's relative stuff, right? So you could look at just the salaries of one district, and you may have a bunch of teachers in that district that are veteran teachers that would have been there more years, and if you're somewhere more years, you make more money, right? So if you have a bunch like this, we'll look at this one right here. So here's one school. This is a school that may have, we'll talk about maybe more years of service. This is less years of service. So if you have more years of service, isn't it going to look like these teachers make more money? Right? And then if you have less years of service here and more, wouldn't it look like this school district pay their teachers less? What if these starting teachers only make 60 grand when you start, but these teachers right here make 70 grand when you start? Would that change things? It would. Yeah. Exactly. Okay. You could say, you could look at this, and since these teachers make 50 grand when they first start teaching, these teachers are making a lot more, but look how many there are. So a district could say, well, we pay our teachers more if you add them all together and divide by, and you find the average of what a teacher makes. But these teachers are actually making 20 grand more than these teachers are, and there's more of them. They can say, oh, but your neighboring district, they're actually paying their teachers, right? We're making more than they are, when we're really not, because it just looks like they're making more because there's more of them than there are. Now, the whole point of it is that you can use statistics to make data look however you want. You have to be smart about it. You have to think about, okay, well, how many teachers are there in the district? How many have been there for 20 years and how many have been there for 5 years? These are all important things that you go into my job, right? So you could find some type of career that the average money that somebody makes, like a pharmacist, the average they make is 150 grand a year. there's only like 2 positions open. You want to look for a job where there's a lot of entry-level positions. You could possibly get a job, right? It doesn't make any sense to go into a career if there's only 2 openings, unless you're just going to be very, very competitive. Great.
There's that like insurance company or whatever going commercial. They had their graph with upside down and making it look like that they're making a lot more than they were, but they're actually like upside down.
I wish you knew which one it was.
You're looking better than you were.
That was in the clock. It was on the news. It was on the news.
They had it upside down.
It makes things look different, and they're not lying. Right? There are examples you can put up the things in different categories, right? Yeah. That's what it says. You have to be mindful of that and know what you're looking at and be able to make sense of the graph. And not just say, oh yeah, that graph looks different than that graph does. I'm going to go with that. Like phone companies, right? They're all going to skew their data however they can to make their company look better. Correct? Okay, let's move on. All right, so here's some other ways. Okay, so what do you remember about these words?
Oh, okay,
Okay, let's hear. Median is middle. Okay, I like it. You have to put in order first, then you find the middle. Tina? When all of them are added together and you find the average. Let's do it with these. Go first, let's know. Let me know. The mode. Is the mode. Sorry. Mode is the mode. Alright, so let's find the median of this data. 4. So the median is going to be 4. What about the mode? 2. Because that has the mode. There's 2 of them. And the mean? 4. So the mean, I'm going to add 2 plus 2 plus 4 plus 5 plus 7. All divided by how much? 5. Okay, check this out. Okay, you guys all agree that the mean was 4. Yeah. Check this out. So this is already 4. How do I make 5 4?
Minus 1.
I took 1 away, so I better give it to somebody else. Let's make it 3. Do you agree?
Yeah.
I made the 5 before, so then I had to give the 1 that came from the 5, I gave it to the 2. How much am I going to take from the 7 to make it a 4? 3. 3, so I could give 1 of them to the 3, and 2 of them to the 2.
What is that called?
Why do you do that?
Why do you do that? I can mess up on that coding.
Okay, that's averaging it without arithmetic. You see what I just did? I took some from 7 to make it a 4 and redistributed it to somebody else. That's what you're technically doing when you add them together and divide by 5. You're evenly distributing them. So if I know it mathematically that it's 4, then I can check it. Like, I'm not asking you to do this. I'm just asking you to look at it and relate it to what we're doing here. Right? Yeah. How do you know to split it into 4? I didn't split it into 4, I split it into 5. Because there's 5. 1, 2, 3, 4, 5. I didn't. I did it this way. I'm trying to show you that that's where it comes from. You can do this only by guess and check method. You have to take some from one, give it to the other, and then find out at the end that there's some left over, so you have to redistribute one. Like if I were to take some and like redistribute them, and I had like 4 left over, then I know I have to give one to each one of them. You know what I mean? Like you have to redistribute it. Okay. Alrighty. I don't think we need this. We're there. We're good. Food scores. Test scores for the semester. So what if somebody does 25% next? And then what would happen to my mean? It would fall a little bit, right? Okay. What about if you got a 90% on the next side? Go up. And the 75 on the next side? It would mostly be the same. Alright, so let's get to, I want this out. Okay, so let's look first at our histogram. Okay, pencil down, just watch me do it, and I'm going to have you copy it down into your folder. Okay, so let's look at histogram. So, Mike says Angels yearly win. Here's their yearly win. 82, 75, 99, 77, 81. So let's make an interval. So if I were to take and try and arrange all those pieces of data into a histogram, what kind of intervals would I have? Like, what would you count by? Do I count by 10? Not by 10, we start at 70 to 80 to 90. That means I only have 4 bars. I would count by 5. So let's start with 70 to 75. Yeah. And then 76 to 80. And then 81 to 85. Does that work? And 86 to 90. 91 to 95. How far do you go? 96 to 100. Alright, so that's my interval. Right? That's how wide they're going to be. And the most important part is your intervals have to be the same width. It doesn't make any sense to be a histogram if they're not all the same width. So if you're going to count by 5, you have to count everything by 5. It starts at 75. We could start at 76, but then we just need, we're counting by 5. You have to count up to 5. Then the next one will be 76. It doesn't really matter. I think you're making it too absolute. Like it's got to be like this. It's your data. However you want to display it. What's really important is that it has to be what? The same equal interval. It's however you want to do it. You're not going to be wrong. Say, well, if you want to start at 75 and go to 89, and then 90, and then 76 to 80, right? You could, does that make sense? You could count this as 71, yeah. So that would be 71, 72, 73, 74, 75, and 76, 77, 78, and 19. You have 5 in each one. I put 70, it doesn't matter because we don't have anything there anymore, right? Okay. Everybody agree? We're good? All these are even? Perfect. Now I'm going to tally. So 82, that will go here. Cross that one off. 75 will go in here. Cross that off. 99 is down here. 77 and then here. 92. Here. 95. Here, 89. Here, 94. Here, 100. 97. Here, 80. Here, 86. 89. 78. 98. I put an 89 in here. Yeah. So 89 that goes clear. Good?
Yeah.
Okay. So my next step is I have to actually put it on the table. Oh, we've got upper tally. I don't have a tendency to put a frequency because I think the frequency is already there. Right? So you could add them up if you want. 1, 2, 1, 2, 1, 3, 3, and 4. Okay, so basically I just have to figure out how many bars I want to use for each one of these. How many bars do I need? 2 bars? I do 3 when I 1, 2, 3, 4, 5, 6 groups. Here's one group, another group, another group. Can I get them all? 1, 2, 3, 4, 5. I can't. What should I do? Am I down to 2? 1, 2, 3, 4, 5, 6. Does that work? Alright. Yes. Okay. So then, technically, this would be 70. Okay? This would be 75. Can I count by 5 here? 80, 85, 90, 95, 100? Because I know that 76 to 100 is in here. Right? I know where that data goes. Even though I'm counting by 5 here, and this looks a little bit different in my interval, you guys see how that's different? Let me add that. Carry. Okay, so what am I even talking about? This is one of the most important parts of doing this, because this is what students will get wrong all of the time. Yearly wins. If you don't put yearly wins, it doesn't matter what you're talking about. Right? You've got to talk about what these numbers mean. If you don't tell me what they mean, then it doesn't make any sense. On the side, all you have to write, because this is the last one, is S for frequency. It just means how many times it occurs. Yes? Guys, let's not, you know what I mean?
Yeah.
I just want to keep going. Okay. We could spend the whole class finding this as long as it takes. Good, the whole class period, right? Let's just try and get the big picture. Okay. All right. So my frequency goes up to 4. I'm going to count it like this. This is 1, 2, 3, 4. Did I have to count it that way? No. I could have counted it like this. 1, 2, 3, 4. Okay? As long as you're consistent with your weight. This is my frequency. Right? So I've got, we go up to 1. So this one's 1. Second interval, I've got 2. My third interval, I have 1. My fourth interval, I have 3. My fourth interval, how many? 3 again?
Yes.
And my fourth interval. Okay. So what do you think the most important part of this is?
Knowing what your tally is.
Knowing what your tally is, good. And here's even more important. Don't use 10.
Well, shit, that has nothing to do with it.
You don't want to use 10 because you're going to make mistakes, right?
Yes.
That's exactly what I do. I was doing pencil and then tracing 10 and I'm highlighting. That would look really nice. Okay, so why don't you go over to your postal now. And this is what I want you to write in first. So under histogram. So a histogram, so in your postal when you open up the top, on this side you're going to have some details about histogram, and on this side we're actually going to show that example of what this is. Okay? So it's a bar graph. It's a bar graph where the bars cut. It allows you to see the shape of the data. Here's some features of your histogram. You must label your X and Y axis. You also should have a title, right? And you must space our units. I'm going to come back to those stuff, but my title actually probably would have been better, yearly win. My yearly win. Yearly win. And here we could have been years. We're not making it the same investment, right? So these are the years. And this is the frequency. Alright, so let's go ahead. Copy that down first, and then we'll go back to the last one. Okay. What's the step? Which age group has the highest frequency? From 20 to 30 years of age, right? Let me make some sense of the data. How many visitors were between 10 and 20 years old? Yeah. Between 10 and 20 years old is right here. And there were 3 visitors. I just put 3, does that work? What?
You don't know what it is.
It doesn't tell you what you're talking about. I could have said 3, it could have been 3 years. Yeah, he's 3 years old. Right? 3 2, could be 3, anything. It's 3 visitors. So part of statistics is making sense of what you're answering, right? How many total visitors? Got 1 here, 3 here, 6 here, 4 here, 2 here, 10, 15, 16, okay, that's making sense of the data. Alright, let's do this with a dot plot this time. Okay, so Mike so said, Angel's yearly win. So the first thing you do with a dot plot is you draw yourself a number line. Draw a number line. What years do you think I'm going to put on my number line? Technically, you've got to represent every single data set. Remember, we got all the dots on the last table? Right? You've got to put every single dot on there. I've got to get every single dot on there. So I would go in years, but where would you start? That's family line. This is kind of part of it, right?
So you go backwards.
So we're going to have to look and see, like, the smallest one's what, 75? So 75, 76, 77, 78, 79, 80, are they all going to fit? They're not. So, what should I do? You're not going to learn to count by 5. You're not going to learn to count by 5 because you're not going to be able to fit individual data in between 77 in there, and be able to know, oh, that dot right there is 77.
But are you saying it's only by year?
We're trying to figure it out.
How do you, but you don't know how, what the years that he won. Like, are those his wins or those the years that he won?
Those are the yearly wins. So, if we're counting this data, by that data right there, we're trying to represent it. Yeah, it doesn't even matter. Because we have to represent this data. It could be anything. I've got to represent that right there on here. I think we need to get away from, I don't know how technical you guys are being. I've got to have a dot plot, and I've got to have all those numbers right there represented on my dot plot. I could go right here. So I could say that 75 is here, 75, 77, 79, I don't think I want to go by 75. Go by 70, 82, 74, 76, 78, that's good. 82, 84, 86, 88, 90, is this going to work good? 92, 94, 96, 98, 100? Am I going to be able to put each one of those pieces of information on there now and recognize exactly what the number is? That's the important part. You've got to figure it out. That's part of the problem. Because this is easy stuff. If we give you your homework, you're going to be like, this is going to be so easy. That's the hardest part. Figuring out how to fit the data onto a graph. Okay. So, 82. I go to 80. Counting by 2, right? So 82 would be right here. That one's done. 75. 70, 72, 74, 76 is there, so I gotta go right in between. Right in between. 99 is here. 77, 72, 4, 6, 78, 77 is right there. 92 is here. 95, 92, 94, 96, and 95 is here. 89. 89 is here. 94. 92, 94, 94 is here. It's right next to it. I'm going to make it smaller. Yeah, there's two different pieces of data there. Okay. 100. 7. Usually you don't see it just spread out, and I really like that about this example. So give me a second. 92, 94, 96, 98, 97. 80. 80 there. 86. 2, 4, 6. 89. We already have an 89. Finally. There's another 89. See how there's two 89s? 78, 78 is here, and 98. Okay. So does this look like it's a really good match for what we're trying to do? It does? It is very uniform. It doesn't tell us much about the data. Right? I just have a bunch of values, a bunch of dots. Wouldn't it make more sense with something like this to like make it histogram? You could almost develop a histogram right there. Aren't I already in equal intervals right now? It would make more sense to say, hey, I'm going to turn this into a histogram, and I've got 1, 2, 3, 4 pieces of data. Actually, we'll go, if I'm counting 70 on this side, I will count 80 on this side. So 1, 2, 3. I could say that this is 3, and 1, 2, 3, 4, 5. 5 in there, and 1, guy or it would make more sense of the data, correct? I'll show you something else. Let's see right spot. Okay, now let's label the dot plot. So what is this dot plot again? What are we talking about? Nice, yearly win. And what are these down here? These years, right? And what's this over here on the side? That's frequency. Okay, I'm not sure you want to put this example in your notes. Let's get this example. Originally, first we'll do this. Make sure I hit everything. So a dot plot is a number line. It's evenly spaced. You have to label your unit. It shows shape. But when does it not show shape? When it's uniform. When it's uniform, the shape doesn't need, there is no shape to it, correct? It's not giving us much data when it's all the same. It would have been different if we would have had like multiple years, but that didn't make any sense as far as data went. And you can go big on this one if you can actually see each data point. On Histogram, you can't see each data point. It's just they're all lumped together. On this one, you can actually see each data point. The example in this way we used on this one was we did one on scores of Super Bowl winners. We did scores of Super Bowl winners. Her data set was these numbers that are on the board right here. Yeah. That was the data set. And so she drew a number line. This will make more sense to you. And she started at, what's the smallest number up there? I'm going to count by 5 cents. We'll start 15. So this is 15. 16, 17, 18, 19, 20. Why am I putting all those dashes on there? Because I actually have to account for, I have to put it in the right spot, right? It's not just a whole bunch lumped together, I have to know exactly where I'm going to put it. So then it would be 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. How about how am I going? 50, 36, 37, 38, 39, 40. Not that fit. That's expensive. My percentage, right? So 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45. 46, 47, 48, 49, 50. And these are my scores. And this is my frequency on the side. Actually, since we don't have anything over here, because there is no y-intercept, right? Or y-axis. Now I just have to put my data on here. So what, we have 17, that's here, 20, Where there was multiples if this was a histogram, right? You can see all of them together. Okay, let's look at the last one. Not the last one. Okay. So let's put them in our last spot. Alright, we're going to do a stem and leaf on this one. Stem and leaf's my favorite too. It's just easier. You don't have to worry about spacing it out. Right? You just say, hey, how many pieces of Alright, so there's two different ways to do this. Some people make a draft. Make a draft first. We'll make a draft stem and leaf spot. I tell you, doing it twice as much. And you make a draft. Because what happens with these is they have to be in ascending order. What is ascending order? Going higher. So let's make our stem and leaf spot. So let's title it first. This would be nice. Yearly. We start talking in terms of what? 70s? Right? So that would be our first step, would be 7. Our first step would be 7. What will be our next step? 8. 80. Then 90. Alright, so this is kind of what I mean. You know, 75, I've got a 75 here, so that would be a 5. Then a 7. Then, got it? No, 8. Then an 8. Those are in descending order, we're good. Yeah, so we did 75, 77, 78, 80, we've got an 82.
Is it 86 below? Oh, 80, oh wait, no, 80, 80, 80, 80.
So this is what they mean by doing a draft one first. And you could do it this way, or you could just reorder everything. I kind of like doing that. I don't know why. I don't know which one takes more work. What do you guys think?
So you got it.
86, 89, and then my 90s would be 99. Hang on, I'm trying to get my 2, 95, 94, 97, 98. Alright, so I have to rewrite that. Yeah. So, 7, 8, 5, 7, 8, 0, 2, 6, 9, 9, 2, 4, 5, 7, 8, 9, and 0. It's also really important that everything is uniform like that, because then you can actually see the data, right? The curve in the data. You know that there's the most is in the 90s, right? Alright, so copy that down. First, let's do oh, we need C also. So my C here would be 7 dash tells you what we're talking about. Alright, let me give you the part that goes on your phone wall, and then I'm going to let you guys get started. So, this plot is a stem and leaf. It needs a title. It needs a key. It's written in ascending order. You can see the shape. You can see each point. Alright guys, for the sake of time that I don't have all of my today, we've only got 5, 10, 15, 20, 25 more minutes. I need to get through the box and whisker. So I'm going to do that quickly, and then I'm going to give you the rest of the time to talk to you. Okay, so I need everyone's attention. So the box and whiskers is the most complicated one. Okay, let's move on to the next one. Alright, so what do you remember about range?
It's the biggest or the smallest I can try. It's the chapter is the smallest I can range. So that range is.
This range is 5. If I was talking about, and this would be the worst scenario in the world, if I had 5 children,
Whoa.
and they were ages
Too short.
2,
Too short.
4, 5, and 7, right? Now we have
So you're twins. Yep.
2 years old.
It doesn't make it again. You never know.
But my range of ages of my kids would be my 7-year-old minus my 2-year-old, 2 of them. 5 would be my range of ages. Okay? Alright, so let's look at this. Let's look at a box plot. So what's different about box plots is you're looking at the percentage of the data. So the median is right there in the middle, right? Your minimum is your very bottom point, your maximum is your very highest point, and then you've got these quartiles. We call this one quartile 1. This one's quartile 3. Why do we have a quartile 2? Because the quartile 2 is the median, right? So technically you could say 50% of your data is below the median and 50% of your data is above the median. Let's work with that. So the inner quartile, here's another piece of information. The inner quartile is looking at the range between the quartiles. So you can kind of look at data this way too. You can say in between quartile 1 and quartile 3, there's actually 50% of the data. Correct? So there's always 25, 25, 25, and 25. So the inner quartile's got 50%. Let's do this. This is called a 5-number summary. So I've got all these numbers up here. What's the first thing I want to do? I'm going to put them in order so it can make more sense in order. So I've got, looks like a 3 up there. 3, 7, 10, 10. 10, 10. 11, 13, 15, 19, 20, 24, 20, and 24. Do I have everything?
Yes.
Okay, good. Let's move this down. All right, let's talk about the things that I know for sure first. So my minimum is 3, and my maximum is 24. How do I find my median? Yeah, go from the end in. I'm not going to talk about because I'm still going to use the
I would do that if it's even or odd.
Okay, so
Because you have to see it. Well, if you look at even or odd, then you know.
between 11 and 13, the median is actually 12. Now here's the only part that is confusing about this. When I'm finding the middle of this side, you're looking at 2 different things. This side, I'm looking at all these numbers, right? Does that make sense? And this side, I'm looking at all these numbers and finding the middle of them. But let's pretend, just for a second, let's pretend that I didn't have 11 and 13. I just had 12. If you see that 12 was my very middle number, then I would only be concerned with finding the middle of these and the middle of these. Because you can't use 12, and I'm going to erase this in a second. This is my middle number 12. I can't use 12 with this side to find the middle, and then use 12 with this side to find the middle. So when you have 1, 2, 3, 4, 5, 6, 7, 8, 9, you have an odd number, you've got to take the middle and take its own number. Does that make sense? And then you find the middle of this side and the middle of this side. Which isn't the case with this one. We're actually lucky because it's an even number. And since it's an even number, I get to use all of the numbers. Does that make sense? Is 11 my median? No, so I'm going to use it to find my first quartile. Is 13 my median? No, so I'm going to use it to find my other quartile. So let's do everything first. So here is my 11 and my 3, my 10 and my 7. So here is quartile 1. 13, 24, 15, 20, 19 is quartile 2. Quartile 1 is 10. And quartile 3 is 19. What's my interquartile range? 19 minus 10 is 9? What's my ultimate range of all of my data?
21.
24 minus 3 is 24. Now this one's actually the easiest one to draw.
Yes.
Right? So it just takes a little vocabulary to understand what we're doing, but it's the easiest one to draw. So the first thing you do is you draw a number line. So my number line, and we're talking about, I don't even know what we're talking about. What are we talking about? It doesn't even say. Let's make something up. If my minimum is 3, so my maximum is 24. How about what? Apps in your phone. Sound good? Number of apps on somebody's phone in the phone. So it's all the way down from 3 and all the way up to 24 would be my math. Okay, here's what you do. You draw, first of all, you need to draw a nice solid scale. So we're starting at 3, so I'm going to start at 0. And then I'm going to count by 5, so that's 4. We're going all the way to 25. So 0, 5, 10, 15, 20, 25. So that's our first step to draw ourselves number line. The second step is to draw 3 different lines. What 3 lines do you think I'm going to draw?
The median and the 24.
Yeah, I want all 3. I want the quartile and the median. So I've got a quartile at 10. I've got a median at 12. And I've got another median at 19. I draw a box around it. Then I draw my min and my max. So my min is at 3 at the dot, and my max is at 24. And then I draw my That's it. That's your 5-number summary right there. Minimum, maximum, first quartile, second quartile, median, and third quartile. So this basically tells us that 25% of my data is here, 25% is in here, 25% is in here, and 25% is here. So there's a bigger spread here, and there's a whole bunch in there, right? See that? It's more compact in there. It doesn't mean there's less data in there. It means that the numbers are closer together in there. Does that make sense? Okay. So I'm going to go ahead and do your second homework. And you guys can start on whatever you want. So we'll start tomorrow, and you guys have